Okay, I think we're live. Let's do this. All right, so this is the first time streaming for me with a new idea that's just beginning. So bear with me. Hope audio is okay. All right. So what I'm here to talk about is the practice of AI combat. This is something new I'm working on. So I'm just going to get right into it. What is AI combat? AI combat, the way I look at it, is contests of AI feats in simulated environments. For now, that just really means AKI play. It really just means AI playing video games. Um, I think it provides us the opportunity to test and break the limits of known AI techniques and processes. It will drive the progress of AI in both bespoke and generalized use cases. That just means like specific use cases and more general. Uh, Consensual. I think this is part of AI combat is that all parties, all systems involved are in agreement. This adversarial uh, encounter is agreed upon. No one is forced or tricked into AI combat. Most importantly, humans, but also systems. So there's no like hacking or anything like that. And that all competition is in the spirit of greater progress for both humans and AI. So the adversarial models that I'm considering are AI versus static system. This is just like AI versus computer. Like usually when, at least when I was young, when we played video games and we play against a computer, it meant we were playing against the game. So that's why for here I just have AI versus static system, classic video game adversary, AI versus AI. Um, this is would be on some simulated or video game environment. AI versus human. This is like what we're seeing now with StarCraft and Dota, of DeepMind and OpenMind. AI taking on esport athletics, or excuse me, esport athletes. And I think eventually we don't see this so much yet, but AI and human uh, teams where the AI and humans are collaborating in real time in a competitive nature. That's one thing I think I want to mention here is this is a real time competitions. So this is a living document. Everything I'm working on here, it's currently in my Euclino account, but I'm going to find a better way to expose this. Maybe I'll put it in a GitHub gist or something like that. But for now, this is just where I dumped all my thoughts on this. All right, so that's kind of the what of what I'm thinking of. This is the really practical explanation. Just AI playing video games. Very simple. I think this is something a lot of people can get excited about, and I'm excited about the prospect. Um, so yeah, let's continue on. The why. So this is my inspiration for AI combat. Background. Let me just read this to you. It's important. Current AI use cases are driven by corporate enterprises to maximize revenue. This isn't inherently evil, but we have seen significant impacts to humanity that we didn't expect, and that I think we can all agree are not necessarily positive. Um, I think AI as a technology should be optimized for the greater good of mankind and not necessarily to drive profit for enterprise corporations. This is just saying that when we approach an AI, or excuse me, when we use AI to approach a problem, I think it should be done as much as possible to benefit mankind at large, rather than through a capitalist, profit-driven structure. I'm not an anti-capitalist. I just think that um, the values of a large corporation are not always necessarily aligned with what's good for people. AI being such a new powerful technology that is being used more and more is not. It should be used discriminately. But I don't think that we can expect companies to self-regulate, and so I think what would what a good practice or a way to approach this is that AI is essentially taken by the people, and the development and progress of that is driven by some more amorphous uh, uh, group of people that is fluid and changes, is diverse, but is not necessarily all driven by the same goals. But that in that we find ways that we can impact humanity in a positive way. So my hypothesis around this is that AI will continue to be used for purposes not aligned with the good of mankind until there is significant incentive to do otherwise. So I think the idea of AI game contests or AI contests um, will drive that progress, and that can be either uh, implemented with like no specific problem to be solved, and that AI will benefit from that, and that a use case is not necessarily selling something or optimizing a certain function of a process. And I think even beyond that, the contests can be created that will largely benefit mankind. Kaggle has done a lot of this, uh, but I really just want to make this um, something a little more interactive and more fun and more accessible than Kaggle eventually. Um, the other thing, I think that the potential of AI will always be inhibited by a lack of diversity, both in use cases and practitioners. I've already touched on these concepts. As long as we're optimizing for selling things online, advertisement targeting, or financial trading algorithms, that's all that AI is going to be the best at. We need to find ways to incentivize AI to be good at other things. And then my last hypothetical point on this is that I think we're seeing the emergence of the fact that AI agents, arguably not unlike humans, are most efficiently forged in adversity. Uh, you see the rise that AI has really started to become productive in that it creates under adversarial networks. We'll talk about this more right now. Just if you've seen a lot of the AI art that's coming out, that comes out of essentially pitting one AI against another. And there's a lot of more examples about that. But I think if we approach that from a more meta place, whereas AI agents are, seeking the same goal, we'll see that evolution move faster. And in the spirit of the fact that this framework is kind of based in I misspelled principles, based on the idea of martial arts, which I have a long background in. I've put together a few initial principles of AI combat training that I'm going with for now. These could also change. But the four for now are humility, in the face of wielding in the face of wielding AI agents for the good of mankind. Diversity, both in or not only diversity in use case, practice, approach, and community. Adversity in a consensual and non-destructive model uses most efficiently drives progress, and that curiosity will drive the other three principles. Let me just kind of briefly touch on these four principles for those that I haven't. Humility, when you begin to train or implement an AI agent, you are using technology that has developed over many years. You could argue from even before we were quote unquote humans, uh, technology that has been developed. But more recently speaking to computation and even just the models you may use are all built by generations of people, and we should be aware of that and respectful of that. I think when using an AI agent to attack a problem, uh, and understand that your role, while maybe it's the end of some expression, is not necessarily your role is not necessarily um, one that should be thought of as superior to everything that's come before. Diversity, I've already talked about that a lot, or at least to some extent. Uh, I think there's a diversity of use cases, i.e., multiple games and goals within games, practice. Uh, that's just techniques, different algorithms, computational platforms, whatever approach. That's also kind of speaks to um, practice. Maybe that's redundant. We may change that. And community. That's the more diverse perspectives are involved in AI, and specifically, hopefully, AI combat, the better off the effort will be. Adversity. Um, I'm a fan of consensual. I jokingly put this on my Twitter handle. My personal Twitter is at agg.red. That I somewhat jokingly put, fan of consensual and superficial violence, because I really enjoy watching mixed martial arts. I like training mixed martial arts. I think this opportunity to have adversarial encounters is a boon to progress, and I think this sorry, and I think this becomes even more effective when these adversarial encounters can be done so in a consensual and non-destructive way. So what does that mean? That means that all parties are aware of and agree to the terms of engagement, and that any damage done by an adversary is not long lasting. So what you'll see, so what this means is, like in MMA, you've seen an evolution of martial arts that has, like, in the past 30 years, has just shot up over what's happened in the past hundreds of years, largely because we've created this arena where martial artists can combat or can take part in combat with each other consensually. There's no like forced violence. There's no it's not like war, uh, but they're allowed to refine their art in an arena that provides true adversity. But there are some rules in place to ensure that the practitioner can continue their practice for an extended period of time, rather than in a no rules situation, the practitioner's ability to practice is severely shortened. So I think that's one key point that I want to include in this idea of AI combat. And curiosity is just the whole reason you're here. It's the reason you want to be involved in AI combat, and it will drive if your curiosity is correctly implemented. It will drive the other three principles. Your humility will both come and feed from your curiosity. Like if you're humble, you're not gonna, or if you're not humble, you're not gonna be curious about other things. If you maintain your humility, you continue to be curious. Your curiosity will seek diverse approaches and practitioners to interact with, and your curiosity will also seek out adversity where your hypotheses can be tested. Okay, so that's kind of the what and the why. Let me close this up. So now we're going to kind of move into the how, and this is how I am going to approach learning and starting to map out this framework. So a big part of what I want to do is provide guidance and direction in seeking out those resources. Um, and if there are gaps where I cannot find good resources, I may look into creating them. But largely, I want to be more of a guide and point and directory. So here's if you don't have any knowledge about programming or anything like that, we'll we'll get you. I will point. Well, this roadmap can be used. Um, but first, I want to go over just a couple concepts that I think is important to learning at large. This is a quote. I like it. It speaks to the humility. Excuse me. Um, competent programmer is fully aware of the strictly limited size of his own skull. Therefore, he approaches the programming task in full humility. And among other things, he avoids clever tricks like the plague. I'm not going to try to interpret that. I would encourage you to explore what that means for yourself. This quote, I like to get in the regular practice of every video. I'm going to try to have a quote, just as kind of a piece of inspiration for you to take on your own journey. So here's some concepts of meta learning, the meta learning around AI combat. Commitment and focus. So this is hard. This is where I struggle. Focus on learning only the skills necessary to do what you want to do. If you want to be an AI combat practitioner, I suggest you restrict your focus to the very specific techniques you need to know. And there's going to be a lot of distractions on this path because a lot of those skills have a lot of overlap with other technology practices that we're not currently interested in as part of practicing AI combat. So, and I get distracted, and I'm going to give you some examples of how that distraction happens. Okay, focus on learning only the skills necessary to do what you want to do. If you're not learning web development, this is hard because a lot of the introductory programming tutorials are focused on getting you to being a web developer of some kind, whether it's the front end or server, back end web developer. It's not game development. Game development's fun, but that's not what this is. You will be, as an AI combat practitioner, there's a good chance you'll be interacting with APIs for games. Well, if you don't know what that is, that's okay, but it's not going to be the same thing as building a game. You will be building an agent to interact with that game. Not crypto blockchain development. I know this is exciting. I've gotten excited about it too. This is my day job as I work for a blockchain company. It's not what this is about. And we're not looking to do machine learning for enterprise. There's nothing wrong with this. I'm just making clear, what this is and what this is not. So I would encourage you to commit to building and training optimized AI agents. For now, the scope of techniques to be familiar with will evolve over time. For now, we will focus on deep reinforcement learning. Reinforcement learning and deep reinforcement learning. We'll go through the differences of that. There's a lot of different AI models available out there that will all be a part of this, but this is really kind of what I have the most context on, so that's where I'm going to start for now. And oh yeah, so let me tell you. So yeah, web development is really easy to get distracted by because almost every tutorial points you in that online will point you towards web development. we're going to start with the Python programming language, and that is actually used significantly in the web development world, but it's not uh, but it's not as big as JavaScript. You'll see JavaScript as another language that's used for your initial programming tutorial. It's okay to learn that, but I wouldn't recommend it. There's plenty of tutorials for Python that are free and good, and we'll talk about that a little bit later. Game development, again, yeah, I'm not going to cover that again. You get the idea what I'm trying to say here. If you want to practice AI combat, you should take time to focus and commit on the very specific practice of AI combat. Let me add one more way it's easy to get distracted. You put together this great AI model, or maybe you have a portfolio of AI models, and you want to show them off. That's fine, makes sense, I get it. So what you then decide to do is go build a website to host your portfolio of AI models, and it has cool videos and looks great. And so now you want to learn front end, you want to learn React or Vue.js, so you have to learn JavaScript. Then on the back end, you have to learn some back end server framework, and then you have to learn how to deploy it. And the next thing you know, you spent the rest of your life building a website to host your AI models, and now have not got the love they had when you created them. So that is how it's easy to get derailed from this practice. But I would encourage you that I'm going to try my best to focus on this, and I will probably find ways to get distracted. But hopefully, through these videos and the community that forms around them, we can all keep each other on task. All right. So initial theory of competencies. This is just what I think as AI combat becomes more of a real thing. What will kind of the skills that will be necessary, and these are technical skills. Starting with individual competitors, just basic. So data manipulation. AI is all about data. It's when things are happening. In order for the system, your agent to react, it has to observe, and the way it observes is data. Whether it's visual or something more base layer, technical. Your agent has to be able to consume that data. And once it consumes that data, it has to be you as a practitioner have to be able to make sense of what that data is, and help your model interpret it, and then how to express its response to that data. So data manipulation is a big part of it. Data science is an extension of, or it's the next step beyond data manipulation. It's taking that data and using statistical models or computation or even other APIs to determine your response or what your AI agent will do in response to that data as it comes in. And then this is just some base level like server administration for environment setup. Your server can be anywhere. It can be in the cloud. It can be on your computer. So we'll need to know a little command line tools, and maybe if we want to go to the cloud, we'll need to learn some of that. Those things may actually become easier to use over time as AWS and Google Cloud are moving into this space. And then this team-based competitors. This is more forward-looking, because I don't know that the ecosystem for this is really built out yet. I know I don't really know if this exists yet, like live team-based competitions. I know obviously when DeepMind or OpenAI presents a model to go against either Lee Sedol in Go or someone else in StarCraft or Dota 2. There's a team of engineers and data scientists that build the models and deploy them and set everything up for that to happen. But I don't think that happens in real time. I think the model is just running its own inference on its own. I don't think they're tweaking the parameters or anything at all in real time. But I think it'd be really cool to get that way, where it becomes this collaborative effort between the model and a human making judgments to try to adjust the AI's reaction in real time. But so just thinking through that, I think you obviously need some data engineering uh, to warehouse the data and pipelines for the data to get moved around. This data engineering will be an important piece as an individual competitor too. But I think initially we can do without it. Integration design. This is actually may also be this is for actually so as an individual competitor you don't need this at a platform level. If you want to integrate with games that the integrations don't exist yet, you'll need to be able to consume an API and interact with that. And then learning and inference dashboards. This is just giving you information as competition is happening, and then data science researcher. So I think you need to, as a practitioner of AI combat, I don't think you need to be like a hardcore data science where you're deep in the math and the statistics of it. I think that helps, but I think the APIs on some of the big machine learning frameworks are robust enough that you can get a lot done without having to get deep into how those things work and change them. But long term, for ultimate optimization, it's really gonna come down to people that can optimize the models beyond the standards. So if you're not good at math and statistics, or if you haven't taken this class in a long time, or you never took those classes, don't worry. I think we can still get you a place where you can at least practice AI combat, and then over time you can build that skill set if you want to go further. So those just like an overview of learning AI combat. So where do we start? Okay, so I'm going to try to run through this quick. This video is already probably longer than it should be. Jupyter Notebook. Let me just show. I don't have an example right now. Jupyter Notebook. The next video is actually going to be all about Jupyter Notebooks. The best way to explain it is that it's a code editor. If you don't know what a Jupyter Notebook is, the best way to think about it is a code editor, but it allows you to run your code in a way that's more appropriate for data science and AI research or model development or whatever. And Google Colab is like a free implementation of that that we'll probably use on most of our videos because you get access to their processing power for free for the most part. I think there's some cap to that, but we don't have to worry about that. But this is where I think you should start, and specifically you should use a cloud-based one because if you can run a Jupyter Notebook on your home computer, but if you don't have the technical skills to navigate command line, it's going to be a struggle that you don't need to deal with right now. You'll learn that later on down the line. So I think I'll guide all new AI practitioners that don't have much coding experience to go to Google Colab, and then we'll go from there. So once you get in your Google Colab, you're going to learn Python. There's tons of free good tutorials to learn Python. I'm not going to teach Python on this channel because I'd be reinventing the wheel. Maybe someday I'll see a need for that, but for now I won't. I'm not going to touch it. I will find some resources, and the next video will include that. So as your next steps after you start to understand your Jupyter Notebooks and the Google Colabs. And then we get down into the Python data libraries. So these are used in data analysis and data science. They just allow you to more easily work with data in Python. So specifically NumPy gives you these dimensional arrays and matrices. If you're not down with the math, that sounds intimidating. It doesn't need to be. It's not as intimidating as it sounds. And I think we'll be able to learn together where we don't have to get too deep into calculus. That's my goal because I don't think that I have the time to get back into calculus right now. And then Pandas gives you more robust data manipulation tools and allows you to shape data in ways that it's more portable and more easily to manipulate. Okay, so these are the first big 3 steps. Once you feel at least comfortable, you don't need to be experts with these NumPy and pandas. Those also will find some good tutorials to point people to, and I may have to do some refresher on that myself. So we may see some videos on NumPy and pandas, and then beyond that we have TensorFlow or PyTorch. So these are the 2 big, probably biggest machine learning / deep learning / AI frameworks, and what they these will kind of provide a lot of the tools that allow you to build models and interact with data. When I say framework, that just basically means that it's, the suite of tools that it's like a lot of code that's already written for you. Like, so a lot of like common things that you do as a developer have already been done by other developers that are probably better than us. So they do it much more efficiently. And then we can use simple commands to leverage these existing frameworks, and we'll learn. So what we're going to start out with is PyTorch, which is these are both open source, so we don't have to pay anything to use them. And we're going to go through the fast.ai course, and it uses PyTorch. That's going to be our first big kind of tutorial sprint, is on that. It's the best. Everyone recommends it. Like, paid or non-paid, fast.ai course is the recommended course. They say that you should have a good amount of coding experience before you do that. I'm going to try to get us there without, like, I think they recommend a year of coding. I'm going to try to get us there with less time than that. I'll be working through it, but I also want to build the prerequisites so you can go through, like, we'll find out whatever tutorials make sense, and then you can just go through the bare minimum, Python and understanding computation and programming there, the bare minimum to go into that course, because that course is going to be it's going to take you to the next level as far as AI goes. And then command line. So if you're on a Mac, you can run a lot of things in the background of computer on what's called the terminal. Basically, those are applications that don't have like a window like we're looking at now. We have a browser window. The terminal allows you to run a lot of things that you don't necessarily need to see what's going on. They're more lightweight. They don't use much computation. But the command line allows you to run a lot of these developer tools that we'll need, whether it's on your home computer if you have a Mac, or on like a Linux computer that's like a server on a cloud somewhere. So we'll get into that more. We'll find some good tutorials for that. Environment configuration. This is really just an extension of the command line idea. This is where you're going to set up, like, if you have a game that you want your AI to play, your AI agent, you're going to need to be able to set up that game to run in the background of your computer, whether it's your desktop computer or a cloud computer. And then you're going to want your AI agent to be able to interact with that. You need those things to run concurrently and talk to each other. So that's what environment configuration is. And then you're also going to want to be able to get that feedback and make sure it's, you can work with it. And then finally, we're going to get into deep reinforcement learning. Reinforcement learning in itself is like a big topic. It's really just rewarding your AI agent to do the right thing, what you determine to be the right thing. And so if it learns to seek out that reward, and it's usually just like a number. It's weird that this computer is rewarded with a number, but that's the way it is. And so you can reward it and you can punish it, and you're basically just telling the computer or the AI agent, this is the right thing to do, or this is the wrong thing to do. And so, let's say if an AI agent, like, you put it in a room, let's say it's a video game room, and the AI agent, you want that AI agent to go out this door at the other side of the room. So what's going to happen is this AI agent is going to have a bunch of time to try to figure out how to do that, even if it's just like walking across straight across the room. It's going to first randomly search, so it may somewhat randomly. It may like go left and go into the wall and then start over, and then it may go right and go into the wall and start over. Then it may go to the middle of the room and go left again and then start over. But the whole time you're setting out rewards for it to get to that door. And then deep reinforcement learning just basically, I don't think that I'm well versed to explain that yet, but I'm learning about that, and we will discover it all. So yeah, that went way longer than I expected. I didn't expect to go 35 minutes, but I hope I got through this information. I hope it's not too long-winded, but that's the basis. This is going to be an evolving document, and this is just the beginning of the practice